This conference will now be recorded.
Okay, today we'll discuss joins. This is also very important topic. First of all, what is join? Then different conditions of join. Then if we'll work with join, then what are the various types of join, use of join, then diagrammatically how it looks like, how it will happen, and work with different kinds of join. So what is join in SQL? For combining the data from one table or more than one table, we have some concepts. One is subquery, already we completed, and another is set operator, that also done. Now third one is joins. So these three concepts are there. By using we can combine the data from one or multiple tables or more than one tables. So what is this join? Join is a query only. It is just like a query. We have to write like subquery, set operator. We are writing query only. That's all. So this join will combine the rows from two or more tables. In set operator, it was combining column to column. In join, it will combine row to row. Row to row, it will combining the data from two or more than two tables. So at least two table each required. That two table can be same, no problem. We can change the alias name A, B, X, Y, and we can join. But at least two tables should be there. Like in set operator also, two sets are there. That two sets can be same, no problem. But at least two sets are there. So same thing here. We need at least two tables, and using those two tables only we can combine in the data. That can be table or that can be views also. Okay, so what is view? We'll discuss later. That next topic is objects. In that views will come, views and materialized view. So views, using views also we can join, using tables also we can join. Same process. View is also one kind of table only. Oracle and other databases perform a join whenever multiple tables appear in the from clause of the query. So whenever from clause we are using, what we are giving, we are passing the data. In which way? Either table name we are giving, or we can give some alias name, or we can give some other query. So whenever we are giving any table name or some other query from clause, one if you are giving, then fine, from HR.employees, fine. If two tables, three tables if you are doing, then what will happen? It will take a lot of data from both the tables, cross multiplication will happen, and so many unnecessary row it will come. So like employees comma departments. So in employees table 100 rows are there, and in departments table 200 rows are there. So total how many rows will come in the result? 100 multiplied with 200. So 20,000 it will come. Out of all those 20,000, 95% or 99% rows are unwanted rows, unnecessary rows, invalid rows. So we have to filter which are valid, which are invalid. Invalid we don't want. Unnecessary it will come and it will get confused, and a lot of memory space also it will take. Okay, so whenever from clause we are writing and we are extracting the data from multiple source in the from clause, either query or alias or table or view, anything. So if it is multiple in the from clause, then we can take the help of join. The select list of the query can select any columns from any of the tables. So suppose 5 tables we are joining, then in one table 10 columns, in another table 20 columns, in another column table 30 columns, like that it will be there. It is not necessary that all columns from all table we have to mention in select clause. Which are required, that only we can mention. Which are not required, ignore that. If any of these tables have a column name in common, then you must qualify all references to these columns throughout the query with the table names to avoid ambiguity. Okay, so departments is one table and employees is one table. In both the table, department ID is present. So whenever we are writing in the select clause, department ID if you will mention, then from which table it will take, it will conflict. That is called as ambiguous. Sometimes it will happen in your query also. It will throw one error message, ambiguous data. So that means one column is there which is present in both the table but not mentioned clearly. So database is not able to identify. In that case, we have to mention departments dot department ID, that column, and employees dot department ID, so that easily it can understand that okay, this department ID is present in both. And this first one is from departments table, second one is from employees table. Or in from clause, if you are giving the alias name from employees E, from departments D. So D dot department ID, E dot department ID, that also we can write. Join means to combine something. In case of SQL, join means combine two or more tables. So the very basic meaning, join means combining two tables or more than two tables. SQL join clause takes records from two or more tables in a database and combines it together. So record by record, row by row it will take, and final result it will display. Most of the join queries contain at least one join condition, either in the from clause or in the where clause. So based on the scenario only, in where clause we can mention or in from clause we can mention. So where clause will be very rare cases need to use, where some condition if you are giving that condition, instead of condition some join clause if you are writing join keyword join condition, then we can give that. That is very rare cases, but in from clause frequently need to use that join. To execute a join, Oracle database combines pairs of rows. Okay, so pairs of rows it will take. Two rows we are combining from two tables. One row will come from first table, another row will come from second table. So total two rows. Whenever two rows came, in output it will display as one row only. Those two will form again one row, and final output will be one row. Similarly, second row, it will come from both the table. So finally it will come as one row. In that way only it will display. Okay, the columns in the join conditions need not also appear in the select list. So in join condition, which column we are joining, like department ID, we are joining. So employees.department ID equal to departments.department ID. So here the join condition is giving with the column name department ID. So it is not necessary that department ID column can be mentioned in select clause also. That is our choice. If required, we can mention. Not required, don't mention. Like in group by, some columns we are mentioned. So those columns should be present in select clause also. That is one rule in group by. But here in join, it is not like that. Any column we can mention in join. Any column we can mention in select. No rule or no hard and fast that both should be same column name. Join is performed whenever two or more tables are joined in a SQL statement based on a common field between them. So at least one common field should be there in both the tables. Then only we can do the join. It returns all rows from multiple tables where the join condition met. To execute a join of three or more tables, suppose three tables we are using and doing the join, four tables we are doing, five tables. So one by one it will happen, the join. First table, second table it will join, second, third, fourth, fifth, like that it will join. So at a time only two tables only it can join. Okay, these are various types of joins. Below are the different joins used in SQL. First one is cross join, second is natural join, third is inner join, fourth is outer join, and fifth is self join. Okay, so natural join and cross join, these two are not using. Inner, outer, and self only using in the real time, and in interview also you will get these three types of join only always: inner join, outer join, and self join. So what is cross join? Cross multiplication will happen. Suppose one table is there, here 10 rows are there, another table we have 20 rows are there. Okay, suppose this is A table and this is B table. So whenever join, if we will do, first of all cross join will happen. That is common, compulsory. First time cross join will happen. After that, any kind of join we are giving out of all these, it will filter from that cross join records. So first cross join will happen. After after that, If we are giving suppose left outer join or equijoin or non-equijoin, then what is the logic behind this? Those things it will filter from that cross join result and final output it will come. That's why I need to understand about cross join. So first of all, cross join. What will happen? This is row number 1, row number 2, row number 3, 4, 5 like that. Here also row number 1, 2, 3, 4, 5 it is there. So each and every row will be combined with each and every row in both the table. Permutation and combinations will happen. So first row will combine with first row. So first row is coming from both the table. So whenever it will come to the result, finally it will display in one row, not in two rows. So both are coming from different tables, so two row we can consider. This is one pair. So from this pair, it will form in one column, one row, and finally it will display this only. Suppose here employee ID is there, employee ID, then department ID, then name is there, then city is there. Here also few columns are there. Suppose uh, department ID, then location, then another we can give telephone number, and another is address. Different columns are there. One column is common, department ID. So whenever it is joining, first row cross join, then what will happen? It will take one row EID, department ID, and city, and some other columns are there. So that will come in one row. From here also, this first row will come, department ID and all those things. Now, in our output, what it will come? All these four columns here in this one row, and all these four or five columns from another table that is also in one row. So total 4 plus 4 or 4 plus 6, 10 columns it will come in the output in one row only. Similarly, this first row again it will cross multiplied with second row. This first row will cross multiplied with third, fourth, fifth, sixth, seventh, eighth, like 20. So how many rows it will come? 20. Now only first row is cross multiplied. Similarly, it will start with second row. This second row will also cross multiplied with all these rows 1, 2, 3, 4, 5, 6 up to 20. So 20 it will come. Third row again 20. Similarly, all these A table rows, total 10 rows are there. So all those 10 rows will cross multiplied with all 20 rows. So total how many combinations will happen? 10 plus 20, total 200. Okay, so out of 200, many are invalid rows. So to take only the valid rows, these are few different types of joins are there: inner join, outer join, self join, so that it will ignore the invalid combinations and it will take only the valid combinations. So any kind of join we can do, first of all cross join will happen. From that only it will filter the valid scenario. Okay, so initial join is cross join. Some problems happen. That's why they can come up with some conclusion with some new kinds of join: inner join, outer join. Under inner join, again it is two types. One is equijoin, another is non-equijoin. Non-equijoin also giving so many invalid scenarios nobody are using. So equijoin only they are using. So under inner join, both are there. One is valid, another is invalid. That's why many people are telling inner join or equijoin. Any one you can tell, that is fine. It is understandable. But equijoin is coming under inner join only. Natural join, business scenario cases only it will come, and here no need of any condition. Direct we can give that. That is natural join. Naturally it will be join. Automatically it will be join. Outer join. So one is left outer join, another is right outer join. So whenever we'll write the join condition, one table will be in left side, another table will be in right side. So some logic behind left side table, some logic behind right side table. So left side logic if you are adding, that is called as left outer join. Right side logic if you are adding, that is called as right outer join. And both we are adding, then that is called as full outer join. In some databases, it is called as left join, right join, full join. That is also fine. We can tell that. Left outer, right outer, full outer. Instead of outer, ignore that also. Direct you can tell left join, right join, full outer join. Both are same only. And last one is self join. So self join means within a table itself we have to join. A is a table. So we can give one alias name of A as X. Same A table alias name we can give as Y. Now we can consider X is a table and Y is a table. Then we can join. So this type of join is called as self join. Within a table itself, same table, no separate tables. Table will be same, alias name will be different, and then we can join using this alias name. So in that case, it is called as self join. So these are in high level what are the different types of join and what are the logic behind that, how it is coming. Now practically we'll do all these joins with some examples. So before that, diagrammatically we can see self join within the table. It will join table itself. A is a table, same table only it will join A. Alias name will be different, XY can be given. Cross join, each and every row will cross multiplied with each and every row. So in table A, 3 rows are there. In table B, 3 rows are there, X, Y, Z, A, B, C. So whenever cross multiplication will happen, A will combine with X row, means first row, second row, first row, third row. Total how many combinations? 3. Similarly, B, BX, BY, BZ, 3. CX, CY, CZ. So all types of combinations are here. This is one combination, this is one combination, this is one combination. Similarly, B to here, B to Y, B to Z, C to X, C to Y, C to Z. All combinations done. So total how many? 9. 3 cross 3. If here 3 is there and here 4 is there, then 12 combinations. If here 5 is there and here 6 is there, 30 combinations. So just it will do the cross multiplication with each row to each row. It will not skip any other row. Next is left join. Table A is there, table B is there. Like set operator, union, intersect, those operators are available under set operator. So what is intersect? Intersect means some common parts are there. This one. So here both tables are present. A few data are present as common. Maybe department ID column or some other columns are there, which are the common data. Okay, so whenever we'll do the inner join, under inner join, equijoin is coming. Non-equijoin, ignore that. That is invalid scenario like cross join type. So whenever we will do inner join or equijoin, only the matching part or common part only it will take. Like which one? Offset operator intersect. So it will behave as intersect. This inner join. Only the matching part or only the common part it will take from both the tables. Other parts it will not take, which are unwanted and which are not required. If left outer join we will do, so inner join is a valid scenario. First of all, this cross join will happen. From cross join, it will take only the common part which are present in both. That is called as inner join. From this inner join, again it is derived these two types of join. One is left join, another is right join, and another is full join. So the base part is inner join only. Okay, so on top of this inner join, it will take the extra data from left side table. So this is in left side table, this is right side table. So inner join it will perform first. Then which are not same, not common, not matching from left side table, that data also it will take plus this data plus this data which are not matching, means up to this whatever data are present with all the column names. In this case, it will be called as a left join or left outer join. Similarly, this inner part, this common part, which are available in both the table, plus right side table, which are not common, extra, that also it will take. So in that case, it can be called as right join or right outer join. And next, inner join plus this left part plus this right side part. All those together if we are taking, then that is called as a full outer join. So in this way different types of joins are there. Now we can take one small example to understand with some data, and then we can go for the employees departments table and we'll do. Okay, ABC is a table here. Employee ID is a foreign key in this ABC table, employee ID. So here 90, 20, 20, repetition is there, duplicate is present. Foreign key can contain duplicate value also. Then null also present. Foreign key can contain null also. But primary key will not contain null and primary key will not take any duplicate. So here this employee ID is a key column. ID related columns are key columns. Region ID, employee ID, location ID, city ID, country ID, employee ID, department ID, all these are key columns. So out of all those key, here employee ID is considering as foreign key, and in XYZ is another table. Here also employee ID is there. Column name is different, E underscore ID, but the meaning is same, employee ID only. This is also employee ID, this is also employee ID. Only column name is different. So here one common column we are getting in both of these table, ABC table and XYZ table. In XYZ table, E underscore ID is a primary key. All are unique value, 10, 20, 30, 40. All are unique value, no duplicate and no null. So we can consider this as a primary key. Now parent-child relationship is there in this fourth table with one common column. Okay, so this common column will be the reference for combining the data, referential integrity. Now whenever we'll join, first of all cross join, then what will happen? 90, this row will join with this row, first row, and how it will display, we can mention here, first row. Okay, so this first row of second table. Okay, so first row from both table is taken. Now in output, how it will display in one row only. So it went to one row. This is first combination. So here you can see employee ID is 90, employee ID is 10. So both persons are not same. How they will be same? Not same, but it is displaying in one row. 90 Pune Physics 4, 10 Shruti 90,000. So both persons are not same but in same row. Then this is meaningless. Similarly, this 90 will combine with 20. In one row it will display 90 employee ID and 20 employee ID, not same. So both are different person. In same row it will display, then what is the meaning? Meaningless. Similarly, 90, 30, meaningless. 90, 40, meaningless. Similarly, total how many rows it will come? Here 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4. So total 24 combinations it will come. All row to all row it will combine, and 24 combinations it will come total. Out of all these 24, few are valid that we have to identify using inner join. So which are valid now? Okay, 90 not present here. 20, yes, here it is present.
Yes.
So this 20, if we will join, then that is the valid scenario. So here 20 we can take 20 from this line and 20 from this line. Both taken as a pair. Now from this pair, it will take into one row whenever it will display in the output. So 20 employee ID, 20 employee ID. Few informations of employee ID 20 is present in one table, few informations are present in another table. Now we are clubbing those and taking all informations of employee ID 20. So employee ID is 20, he is from Hyderabad, he is in chemistry department. What is for? Okay, this is just for counting combination, you can ignore this. Now the same persons is available in another table also 20. So both are same. So whatever combinations we are taking in one row, this is the correct valid. The 20 employee ID person name is Rajesh and he is getting salary 10,000. So complete informations we got. Few are available in XYZ table, few are available in ABC table. So this is a valid one. So wherever both are same, in that case only we can tell that is coming as a valid scenario or valid row. Similarly, this 20 will combine with others 30, 40, 10, those are invalid. Now 30 will start. 30, 10, it will be invalid. 30, 20, invalid. 30, 30, yes. So this will be one valid scenario. 130 will come. Now 30, 40, this is also invalid. Next 80, 80, 10, invalid. 80, 20, invalid. 80, 30, 80, 40, all are invalid. Null, null 10, null 20, all these are invalid. Now 20, 20, 10, invalid. 20, 20. This is 10. So this is another row it will come. 20, 20. Okay, this 20, 10 invalid, 20, 20, 20, 30 invalid, 20, 40 also invalid. So finally, how many it will come? 3 rows. So total it was generating total combinations 24, but out of all those, these 3 are valid. So these 3 only we can get if we will do the inner join. If we will not do inner join, cross join only we will do, then all the scenario it will come, all the combinations it will come. Unnecessary it will take time consuming and lot of data will get, lot of confusion will happen and it will be mistake also. Okay, so first of all it will do the cross join and from that it will filter the valid rows. Those valid rows which are forming, those are the inner join only. Okay, so these 3 it is coming finally. Now using this employees and departments table we can do one join. So first of all we can do cross join. So how to write the cross join? Select star we can give, suppose star from HR dot employees. HR dot departments. Okay, here how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In one line only we can write 11 columns. How many rows are there? 107 rows. Similarly, from departments table, how many rows and columns are there? 1, 2, 3, 4. 4 column. And how many rows? 27 rows. Similarly, another table we can take locations. How many columns? 1, 2, 3, 4, 5, 6. 6 columns. How many rows? 23 rows. Okay. Now we can combine it using join. Select star from, select star in one row we have written from clause, table name we are giving. So 2 tables we are taking with HR schema only. So HR dot employees comma HR dot departments. From 2 tables we are taking. No join condition, nothing. Simply we are writing multiple tables. Now if we will execute, then what will happen? Cross multiplication will happen, these two. So here 107 rows are there and here 27 rows are there. If both will multiply, then total how many rows it will come? All the combination. First row will be cross multiplied with all 107 rows. Means from this 107 rows, one row will combine with all 27. Second row will combine with all 27. Third row will combine with all 27. So finally 107 multiplied with 27 it will come. Total how many it is coming? Count of rows 2889. Okay, we can check whether it is calculated properly or not. Calculator 107 multiplied with 27, 2889. 2889 it is coming. And column if you will take, then how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 16. 16 or 15. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. So here 11 columns are there. Here 4 columns are there. All column it is coming. All 11 columns from this employees table, all 4 columns from this departments table. So 11 plus 4, 15. So here total how many columns it is coming? 15 columns. And 2889 rows. So this is happening in cross join. So simply we are giving the table names in from clause. That is called as cross join. Okay, now out of all these, many invalid scenarios are there. So here we can see department ID is a common column in both the table. In departments table, that is primary key, and in employees table, that is foreign key. In employees table, department ID 10, 10, 10, 10, 20, 20, 20, 30, 30, 30 is present. So that is the foreign key. And in departments table, it is unique wise, no duplicate, no null. 10, 20, 30, 40, 50, 60, in that way only it is present. So that is primary key. So we have primary key, foreign key. Both are present in these two tables. Parent-child relationship is there. Referential integrity is there. Then common column also that is. So we can join with some correct condition, filter condition. So here if you will observe employee ID 100 coming from which department? 90 department. So 90 department is mentioned in employees table, but if we will see departments table, it is showing 10 department. So this is invalid scenario. How one person will work in two departments? And in this table, it is not present, those type of data. Two departments, somebody is working. Those type of data is not present in this table. So this is invalid. Similarly, 90 is multiplied with so many employees of 10 departments. 60 is combining with 10. All these are invalid. So whenever we will get 90, 90 in both the table, then that is a valid. 90, 10 valid. Sorry, 90, 90 will be valid. So out of all these, if you will check, somewhere 90, 90 will be there, 50, 50 will be there, 80, 80 will be there, 10, 10 will be there. Those will be valid. 30, 20. This is also not valid. So here 2000 something it is coming. If we will identify which are same, then it will take more time. If you will scroll up, scroll down, scroll up, scroll down and identify, it is not a means a correct approach. Maybe mistake will happen as a human being manually. If you will do, then mistake also can happen. Time taking process, and so many times we have to do. So unnecessary, this is time waste. So what to do for that? Which are same? 20 20, 10 10, 50 50, 80 80, 40 40, which are same, that only we can take, so that all the valid scenario we will get. So how to write that? Using this only we can extend one where clause. We can write where. Here we can give one alias name for employees E, for departments D. So here one condition we can give E dot, that common column is department ID, equal to D dot department ID. Now which are same, that only it will come. So that those will be the valid combination. Okay, now how many rows are coming? 106 rows. So from both the table, if it is combining, then matching records 10, 10, 20, 20, 30, 30, 40, 40, these type of combinations are 106, which are purely valid. So here you can see employee ID is 20, his name is Jennifer, last name is Wallen, email is J Wallen, phone number is there, hire date is there, job ID is there, salary, commission PCT, manager ID, department ID. So up to this, it is coming from employees table. Now from departments table, department ID is 10, 10, 10, both are matching. Okay, so this is valid. So that person is belonging from which department? Department name is administration department. Department ID is present in this employees table, but department name is not present. So that 10 department ID name is administration department. We are getting some other information also. Next, manager ID. So manager ID is present in this departments table also. So 200, that manager ID is. Location ID. Location ID also we are getting 1700. Okay, so all the complete informations we are getting which are present in both the table. Only one table, then few informations was missing. Now complete informations we are getting. So similarly here, another table also we can write. HR.locations. Again it will be cross multiplied. So already these two are multiplied to 889. And HR.locations also few columns, few rows are there 23. So that will also multiply now. 66,447. Now if you will execute this, how many rows are coming? 66,447. And from this table, location 6 columns are there. So 11 plus 4 plus 6, 21 columns it will come in this output. All columns from all table because star we have given. Okay, so instead of star, if you will give some columns, like here we can give E is employees table. So E dot first name, E dot last name, E dot salary, 4 columns or 5 columns we are taking from employees table. Similarly, D dot department ID, D dot location ID, D dot department name, 3 or 4 columns we are taking from departments table. So in that case, the selected columns means which columns we will mention in the selector, that only it will display. It will not display all the columns. So this star is not compulsory. We can give our selected columns also, which we require. Now this join condition, if will increase with another table, suppose, then how to write? Another condition we have to write. More than one condition, then and we can give. In where clause more than one condition if you are writing, then and operator we have to do. So department ID and department ID in both the table it is same. Now we can join with this another table, locations table. Again you can give here HR.locations, where E dot department ID equal to D dot department ID, and in locations table, departments table, one common column is there, that is location ID. Location ID from department table, location ID from locations table, L suppose. Okay, now we can get the combined data. So here employees table and locations table if you will see, then common column is not there, but departments and locations table common column is there, location ID. So in that case, if we need the complete informations or some location table informations with employees table informations, then two joins we have to do. Because directly we cannot join employees and locations. Indirectly we can join. So locations ID with departments and locations table it will join. After that, the data will come. So those data will be present in departments table also now. Now those data again we can join with employees. So indirectly it can be happen. So finally, if you will do, these are the data. Total how many rows? 106 rows only it is coming. But if you are not giving this join condition, then how many rows it is coming? 66,447. Many invalid rows are there. That's why cross join is invalid scenario. But that is the base part. Whenever any join is coming, from those join we have to filter the valid data, valid combinations only using inner join or some other join. So whatever we have written equal to using equality operator, this is called as equijoin. So why they have given the name as equijoin? We are using the condition as equality operator, equal to symbol. So equijoin they have given. And another is not equal to, means without equal to. It can be less than, it can be greater than, it can be not equal to, it can be some other. So in that case also so many invalid scenario will come. You can just think how it will come, the invalid scenario. There also invalid will come. That's why that is also not considering. Only equality it is considering. And under inner join, one is equijoin and another is non-equijoin, and non-equijoin is also invalid. That's why only equijoin is considering. So many people are telling equijoin, inner join both are same. So you can consider same, no problem. One is valid and that is only we are considering. So this is the syntax how to write the equijoin. And another syntax is there. Similarly, any number of join we can do. Another table is there, suppose job history in this HR schema. So just check job history and which common column is present, that also you can manage here and join. Okay, so similarly 5, 7, 8, 10, any number of joins we can do. Here where e.department id equal to d.department id. Okay, this is first syntax. Second syntax we can take. Okay, so here star we have given. Now in this example we can take some selected columns, not taking all columns. E.employee id, E.first name, E.last name, E.salary, department id, then D.department id, commission PCT, hire date we are not taking, some selected columns only taken, then D.manager id, D.department name. So few columns from employees table, few columns from departments table we are taking. From employees E, then inner join departments D. So which join we are doing, that we have to mention here. Inner join or full outer or left outer or self join we have to mention here. So we are going to do inner join. So inner join is mentioned. From first table, then inner join, type of join, then second table, departments D. Now on which is common column, that condition we can give like this one. In where, which we were writing, same thing we have to give in on here. On D.department id equal to E.department id. A equal to B, B equal to A, both are same. So E.department id equal to D.department id also we can give, or D.department id equal to E.department id. Anything is same, so no confusion here. Semicolon. So if we'll execute this, okay, HR dot. Which column we have given, those columns only it is coming, and only the valid combinations it is coming. 106 was coming in the first syntax, same 106 only it is coming. Okay, so this is about inner join. Two types of syntax are there. The second syntax is applicable in all databases. MySQL, Postgres, MariaDB, DB2, any database you can go, the second syntax is working everywhere. Third syntax is for few databases only, Oracle and few other databases. So always try to remember the second syntax. This is easy also, and all databases it will work. In interview, both you can tell. Okay, so this is about inner join. If inner join you completely understand, then other joins are extension of inner join only. Easily you can understand. Okay, another inner join if you want to do, then we can mention that scenario also, that condition also. Another inner join. So departments HR locations here. Okay, so another inner join HR.locations D on D.location ID equal to L.location ID. And few column names we can give here also from location ID. L dot in locations table, which are the column names? Okay, street address, location ID, postal code, street address we can give here. L dot city, L dot country ID, okay. So these are few columns provided. Now we can execute. From HR.employees,
Alias name is wrong for location table, sir. Location is we are taking D now.
okay,
Location.
okay. L.
Yeah.
Okay, so which columns we have given, those columns it is coming, and total 106 rows it is coming. So in this way we can extend also any number of tables we can join. So in that live SQL, just check under HR schema which are the tables. These are three tables. One is employees, another is departments, and another is locations. So today as your homework you can check what are the tables available. Another is job history, jobs also one table, job history is one table. Like that 8 or 10 tables are there in that HR schema. So you can just go through all those tables, which are the common columns, which is primary key, which is foreign key, check from that constant data dictionary table yesterday we discussed. By seeing also you can check which is the common one. If you are confused from the data dictionary of constant, you can check and join all those tables with all the columns, so that complete informations of HR related informations will get. Some are present in employee, some are in job, some are in location, some are in different. So today as your home task you can do that, maybe 10 to 20 minutes it will take. Try to join all those like this. Inner join, inner join, inner join you can do, and one table, second table, third table, fourth table. So after which table, what table you have to give, just you can correlate all those. All common columns are not present in all tables. Like employees, common column is departments for this departments table. But locations and employees you are taking, then no common column. So first departments and location you can join, then employees and department. So indirectly it is joining employment locations also. Similarly, jobs, if you are joining, then which common column is there? Job and locations is common, or job or employees is common? We don't know. You can just check that. So just check which column is common in which tables, and those tables only you can consider, and all the inner join you can do. 8 or 10 tables are present in that adjustment. Okay, so this is about inner join and cross join. Any doubt from anybody?
No, sir, but I want to ask a question like how many tables we can join, or it's not defined.
Any number, it is not defined.
Okay, any number.
Yes.
Okay.
So in real time, 5, 7, up to that only it is coming, not more than that. But no limitation. If required 10, 20, 30, 50 also we can do join.
Okay, but when we are generating a report, in that report, if you will consider like 40, 45 columns, so there are the like on the my question is that like no limitation, right? We can use like how many columns we have to use from the tables, right?
No, there is no limitation. Any number of columns we can take from all those tables. But if you are
Okay.
working in a project, in the requirement it will mention which columns will be taken. Those
Okay.
columns
Okay.
which are
Yeah.
not mentioned unnecessary, don't take those columns.
Yes. Yes.
Serial number also. First column, second column, third column, which they have mentioned. In that way only you can take. It is not like that all employees table columns will be first, then departments. Maybe first column will be department ID of department table. Second will be employee ID from employees table. Third will be location name from locations table. It can happen like that. In that way only need to mention the sequence. So that sequence wise it will display the result, and this result wise it will generate the report.
Okay. Thank you.
Okay. Any other questions from this inner join or equijoin? This is the base part. If you are clear, then others are nothing, just extension only. Okay. So next is natural join. Natural join is used to create an implicit join clause based on the value of common attributes. Same name in both tables, in the two tables. Natural join does not need any comparison operator, as in the case of equijoin. So natural join, if you are doing, then in inner join what we did, one join condition we have given with some condition, equality or not equal to. So here one condition we are giving based on the common column. Natural join if you will do, then ignore this condition. Don't give any condition. Naturally it will take. It will understand inside only. Database will understand. Database is having that power. It will understand what is the common column in our query or two tables. So automatically it will pick that. Maybe that is not our requirement, but it will pick that. Suppose two columns are common, but in our requirement, one column we have to combine as join condition. So another column if you will take, then wrong value we will get. In that case, it will be problem, natural join. Automatically it will pick. So automatically it will pick means some cases it can be correct, some cases it cannot be correct. Naturally it will pick, automatically it will pick. That's why they have given the name as natural join. So here select E dot first name, D dot department name. From HR dot departments D, mention natural join HR dot employees E. We have not mentioned based on which common column it will join. So it will take departments table, employees table both, and common column it will find out. Database only it will try and find out. And based on that, it will do some kind of join. It is not always inner join. Whatever it will take, some random join it will take, and it will display the result. So it can be correct, it cannot be correct. That's why this is also invalid approach. So cross join, natural join, nobody is using. From inner join onwards only all are using. This is a valid one, inner join. Equality operator we are giving. Okay, so tomorrow we'll discuss other joins and few exercise on join. These are the interview questions effective for this join topic. Explains all kinds of join. What are the equivalent set operators for join? So we have not covered other joins. Tomorrow we will discuss this. The inner join, how we can write in different way using set operator. Then intersect, how we will write using join. Then union, how we will write union all those. So set operator and join we can correlate tomorrow. And which, while combining the data from multiple tables, which of the below approach is faster? So join is combining the data from multiple tables, subquery also, set operator, another is common table expression also we can do. So which will be appropriate, which will be faster in which case? Then what are the difference between inner join, outer join, equijoin, non-equijoin, full join, cross join, natural join, left join, right join? So these are some theoretical questions. Practical query tomorrow again we will discuss in interview.